instead of being asked to clean your room, we've been asked to differentiate a scalar function. So the first thing that you need to do is start differentiating. The gradient, so the grad of a scalar function is d phi over dx, d phi over dy, and d phi over dz. This here is what's called a Nabla, which is another fancy way of just talking about the gradient of a scalar function. So the first thing that we want to do is do d phi by dx. So we're doing partial derivative. If you're not familiar with partial derivatives, I don't know why you're looking at this, but I do have a video going over how to find df dx, df dy, d squared f over dy dx, and so on and so forth and all that stuff. So you can probably see it in the link in the description. So let's do d phi over dx. So you're going to get 4x y z. Then you're going to get 4y cubed. Then you get d phi over dy, so that's going to be 2x squared z plus you're going to get 12xy squared. And then finally, let's do d phi by dz. So that is just going to be 2x squared y. We can now plug this in. So let's do the fancy Nabla. And we're going to have 3 points. So we're going to get 4xyz plus 4y cubed, 2x squared z plus 12xy squared, and then 2x squared y. Now we can go on to the second part. The final step is quite straightforward. So we know that this is the x, y, and z positions or terms, and all we now need to do is represent it in unit vectors. Unit vectors are I, j, and k, whereby this is the I position, j position, and k position. So the Nabla of phi would then be everything here, so 4xyz plus 4y cubed, and then you would have an I plus 2x squared z plus 12xy squared j plus 2x squared y k. So now you've differentiated a scalar function and you've used your unit vectors to give it a nice little position.